Hey, everybody, it's Jonathan Cohn here at the Bulwark. Last week, Robert F. Kennedy Jr., Secretary of Health and Human Services, announced that at his direction, the federal government was pulling about $500 million in research funds for the development of the next mRNA vaccines. mRNA vaccines, as you may know, that's the type of the medical breakthrough that led to the COVID vaccines. Secretary Kennedy said he has decided after he said we reviewed the science, we listened to the experts and decided that the vaccines were the risks outweighed the benefits and they were not effective. I think, his citation of that was important because I think people hear a government official making these pronouncements, talking, citing scientists, citing studies, and sounds like they know what they're talking about. It struck me as a little odd because all the researchers and physicians I know think mRNA vaccine was a terrific innovation. They credit it with saving lives. But, I'm not a scientist, so I thought we should ask somebody who really does know this. And we've got somebody, I can't think of a better person to address this. Paul Offit is a professor of pediatrics at the University of Pennsylvania. He is director of the Center for Vaccine Education at the Children's Hospital of Philadelphia. And if you don't recognize him, by those titles, you will probably recognize his voice and his face because he is one of the most widely sought after experts on vaccines and immunology, not just in the United States, but in the world. We're very grateful to have him with here us today. Dr. Offit, thanks for joining us.
Thank you.
Before we get started, just to kind of set the scene here, what was this investment supposed to do? It was $500 million of investment. What was the idea of this money? What were they trying to, what was it going to, what kind of research was it going to support?
Well, so Barda, the RDA stands for Research Development Authority. So the goal is to try and do research in advance of something happening. So, for example, there was a vaccine being studied for bird flu, specifically H5N1 virus. So you could get ahead of that. I mean, I think what people didn't realize is that the reason that we were able to create an mRNA vaccine against SARS-CoV-2, the virus that caused COVID, so quickly was because of NIH. When SARS-1 raised its head in 2002, 2003, NIH started working on a SARS-1 vaccine and had a lot of information on how to make an mRNA vaccine against coronaviruses so that when SARS-CoV-2 raised its head, then we were much better prepared. That's what's going on at Barda. This Research Development Authority is to try and get ahead of the game on things like bird flu, the H5N1 virus.
When Secretary Kennedy announced this, they put out a press release and he made a video. It's about 2.5-minute video in which he explained what HHS was doing. So what I'd like to do is just pull out sort of the key portions of that video and kind of have you react and tell us, because he sounds very convincing. I think lots of people have questions about vaccines. They hear this. It sounds, they assume he knows what he's talking about. Our producer here, Katie Lutz, is going to cue them up and play them. And Katie, why don't we go ahead and show the first excerpt?
mRNA vaccines don't perform well against viruses that infect the upper respiratory tract.
So that's just a basic statement. He's saying these vaccines, they don't work against respiratory illnesses, of which, COVID is one, obviously. Is that true?
Influenza, SARS-CoV-2, the virus that causes COVID, respiratory syncytial virus, are all short incubation period mucosal infections. The goal of vaccines in those kinds of infections is to prevent serious illness, keep people out of the hospital, keep them out of the intensive care unit, keep them out of the morgue. For those kinds of illnesses, you're not going to prevent a mild or moderate illness for long, either after natural infection or a vaccination. Usually about 6 months later, you're still to some extent susceptible to that. So that's the goal, keep you out of the hospital. Did that vaccine work? Of course it did. In 2021, when we had a vaccine, you were 12 times more likely to be hospitalized, 12 times more likely to die if you were unvaccinated than if you were vaccinated. The following year, you were 6 times more likely to be hospitalized and die if you were unvaccinated than if you were vaccinated. Depending on who you look at, this vaccine probably saved between 2 to 3 million lives in the United States alone. And the Kaiser Family Foundation and others have looked at how many people, by choosing not to get a vaccine, basically chose their own death, at least 200,000 and maybe as many as 250,000. Of course, the vaccine worked. I think he doesn't understand the goal of the vaccine.
I'm curious. Why do you think? I mean, I think a lot of people had that impression. They're like, oh, we thought this was going to wipe it out. It didn't. Therefore, it didn't work. Why do you think people might think that?
I think in that first year, 2021, when we had a vaccine, I think it was a little overpromised. I think the notion was that it could stop transmission. And although it can lessen transmission, it's not going to stop transmission. I think people were mandated to get a vaccine, and then they got a vaccine, not necessarily something they were willing to do, but they did. And then they got a moderate illness, which was, they would be home for a few days with, cough and fever and runny nose and feeling miserable. And they're thinking, hey, they made me get this vaccine, and now I'm home for a couple of days with fever. They lied to me. I think we should have explained what this vaccine could and couldn't do right from the beginning, and we didn't do a great job at that.
Yeah, no, I think there are a lot of public health lessons that came out of that hopefully, we learn for next time. Katie, you want to play that second quote for us now?
Here's the problem. mRNA only codes for a small part of the viral proteins, usually a single antigen. One mutation and the vaccine becomes ineffective.
So here we go. I just, just parenthetically, I think one of the things that Secretary Kennedy does a lot is he kind of throws out words that sound technical. He sounds like he's getting into the weeds here of biology and describing that. So what he just said there, Dr. Offit, what do you think?
Okay. So, first of all, the SARS-CoV-2 vaccine, the COVID vaccine, is against one protein, specifically the spike protein, the fusion protein, the protein that sits on the surface of the virus. Viruses usually have one protein that allows them to attach to cells. If you can prevent the virus from attaching to cells by making antibodies against that protein, then you can prevent the virus from entering cells and causing an infection. So we have other single protein vaccines. The hepatitis B vaccine, for example, is a single protein vaccine that has virtually eliminated hepatitis B infections in children less than 10 years of age. We have a human papillomavirus vaccine. Again, single protein, surface protein, which has reduced the incidence of cervical cancer in this country by more than 60%. So he says that, well, by having just one protein, if the virus, for example, mutates away from the recognition, the antibody response against that one protein, that it's completely ineffective. That's just not true. If that were true, if the vaccine was now no longer effective at all, then we're back to where we were in 2019 when the whole world is susceptible. So that's obviously wrong. He also ignores something that's critical, which is T cells. It's not just antibodies that protect you. It's also a part of your immune system called T cells, specifically cytotoxic T cells. So those.
And do you want to tell people what the differences are between very quickly, those different kinds of cells?
Yeah, sure. So B cells make antibodies and T cells don't. What T cells do, at least one kind of T cell, is it kills virus-infected cells. So after the virus has already entered the cell, the T cell recognizes that there's something foreign going on in that cell and kills the cell before more virus particles can be made. So cytotoxic T cells are critical to protection. In fact, I would argue that Dan Baruch, who's an immunologist at Harvard, said it best. He said cytotoxic T cells are the unsung hero of this pandemic. And I think that's right. And the thing about T cells, as distinct from B cells, T cells recognize regions of the virus that are conserved from one strain to the next to the next. So although you have a variety of variants that are formed, T cells recognize that part that's the same on all those variants. And that's generally why you're protected against severe disease, because you have these memory T cells that are generally long-lived. So that is completely ignored by Robert F. Kennedy Jr. in that statement.
So even if there are this mutation in this one part, your body's immune system, these T cells you're talking about, they are going to still be able to destroy the virus, destroy the cells with the virus, and keep you from getting really sick and hopefully not dying. Correct?
Right, and are independent of the virus mutating away from recognition by the T cells. T cells are long-lived and recognize relatively conserved regions on these variants.
Right. Let's go to the next segment.
This dynamic drives a phenomena called antigenic shift, meaning that the vaccine paradoxically encourages new mutations and can actually prolong pandemics as the virus constantly mutates to escape the protective effects of the vaccine.
So I thought this was one of the most notable things he said in that video, because if you translate what he's saying there, at least the way I translated it, he's saying not only did the vaccine is it failing to keep you healthy, but it's actually accelerating the process of causing new mutations so that a pandemic can actually go on for longer, which I thought was a sort of quite a claim. Is there anything to that?
No. So, for example, when this virus raised its head in China in late 2019, SARS-CoV-2 virus, the original strain was called the ancestral strain, or the Wuhan 1 strain. That's not the strain that left China. The strain that left China was the first variant. It didn't have a Greek letter designation. It was called D614G, but it was more contagious. So it's the one that swept through Asia, swept through Europe. And then it was replaced by the Alpha variant. Then it was replaced by the Delta variant. That all happened before there ever was a vaccine. So this virus can mutate away from one strain to the next without any pressure from vaccines, because all those variants were created before we ever had a vaccine. So that's wrong. The term antigenic shift is really reserved for influenza virus, because influenza virus has a so-called segmented genome. So there's different segments, and each segment codes for a specific protein. What happens with influenza is sometimes a whole gene segment is transferred from one virus to the next. That's what antigenic shift is. That doesn't happen with this virus. There is not antigenic shift on coronaviruses. So he's using a term that's applied to influenza virus for coronavirus. And when that happens with influenza virus, then you get a pandemic. Every time there's an antigenic shift, you get a pandemic. It's like the 1918 pandemic, the 1957 flu pandemic, the 1968 flu pandemic, the 2009 flu pandemic. Those were all antigenic shifts. If this virus went an antigenic shift, which means a complete change from what that virus was in terms of recognition by the immune response, then we have a new pandemic. And that's not what's been happening. We have generally controlled this virus. We don't have a pandemic anymore. This virus doesn't change the way we live, work, or play anymore. And although certainly hundreds of thousands of people are being hospitalized and tens of thousands are dying every year, it's much better than where we were, we would have thousands of people dying every day. That's not happening anymore because we've gotten on top of this virus with immunization. So his notion that the vaccine has created these strains that are completely resistant to the immune response induced by vaccination is wrong on its face, because if that were true, we would have another pandemic every time that happened.
Let's go to the next clip. Katie, can you play it for us?
After reviewing the science and consulting top experts at NIH and FDA, HHS has determined that mRNA technology poses more risks than benefits for these respiratory viruses.
So let's leave out the first part of that about who he did or didn't consult. Let's just focus on the second part there. So he's saying the risk is worse than the benefit. And although he didn't say it here, I think if you know his background, if you know what people think, he's talking about what he would say are there were side effects, people were harmed. Just walk us through that. What do we know about side effects, complications? Is there a case to be made that they are worse than the benefits?
So I'm actually on the FDA Vaccine Advisory Committee. When we sat down in December of 2020 to look at the two studies that had been done by Pfizer and Moderna. So Pfizer had done a placebo-controlled 1-to-1 study of 40,000 people, adults, that either got the vaccine or didn't. So because it was 1-to-1 placebo-controlled, 20,000 people got Pfizer's mRNA vaccine. Moderna did a 30,000 person trial. So 15,000 people got the vaccine. So that means that in December of 2020, 35,000 adults had gotten the mRNA COVID vaccines. And we were asked whether or not we thought that was enough information, whether we knew enough to say that this vaccine should be authorized for use through emergency use authorization. Because you don't know everything. You never know everything. The question is, did you know enough? And we voted unanimously yes. But we all held our breath, because you know that the history of medical innovation is that there is invariably a human price paid for knowledge. You know that although you've given this vaccine to 35,000 people, that may not predict what is about to happen when you give this vaccine to hundreds and hundreds of millions of people. That there may be, and it frankly likely will be, a rare side effect. The only question is how rare and how serious. So what happened was we learned really within a few months that this vaccine could cause myocarditis, which is inflammation expansion of the heart muscle, primarily in boys and young men between 16 and 29 years of age. Now, the good news is it was rare. Occurred overall in about 1 in 50,000 people. And it was generally mild, self-limited, and, transient, short-lived, which is distinct from the myocarditis caused by the virus. I mean, when this virus first affected children in this country, 2020, 2021, we had 3 floors of COVID at Children's Hospital of Philadelphia. And most of those children had something called multi-system inflammatory disease, which means they got sick, they got better, and then they came back with this sort of multi-system disease that involved the lungs, involved the liver, and involved the heart. And so we saw severe myocarditis caused by that virus, where children would have to go to the intensive care unit, and there were deaths associated with myocarditis caused by the virus, but not the vaccine. And in fact, if you look now over the last 3 years, myocarditis has virtually disappeared. I think this is one of the safest, best tested vaccines ever made, ever. And in terms of benefits, of course, it's beneficial. I mean, if you look at people who are getting hospitalized and who are dying, they're invariably not vaccinated. Vaccination continues to save our lives. So he makes it up. I don't know what he's talking about when he talks about that. Now, arguably, look at what happened in February 2021. In February 2021, we authorized Johnson & Johnson's adenovirus vectored vaccine. So that wasn't an mRNA vaccine. It was an adenovirus that had that sort of like a Trojan horse virus that would go into your cells and deliver then the gene that coded for the spike protein from SARS-CoV-2. So again, the studies were in tens of thousands of people, but not millions of people. So again, what would happen? And what we found was very quickly, there was a very rare side effect, which was clotting. And it could be clotting in the brain. And it could be fatal clotting in the brain. It was rare, maybe 1 in 250,000 people. So you weren't going to pick that up in a study of tens of thousands of people. But when it was given to tens of millions of people, you saw that. And it was a serious side effect, so much so that by May of 2023, that vaccine was off the market. So I don't know what he's talking about with the mRNA vaccines, which are a remarkably safe. I mean, not absolutely safe, but remarkably safe vaccine.
Well, one other question, I think some people think, well, this is so new. It's a new technology. So we don't know what's going to show up in 5 or 10 years. And that should give us pause and make us question these vaccines. Is there a reason to worry about what we might discover 5, 10, 20 years from now?
I don't think so. I mean, certainly vaccines can cause serious problems. Vaccines can cause permanent damage. Vaccines can cause death. But when that happens, it's invariably because of the immune response to the vaccine. So for example, the influenza vaccine is a rare cause of something called Guillain-Barré syndrome, when the body basically, by giving the vaccine, you're inducing an autoimmune response against your own nervous system. And that's what Guillain-Barré syndrome is. But it happens really within weeks of getting the vaccine. There was a flu vaccine, an influenza vaccine given in Europe called Pandemrix for the 2009 pandemic. And that caused narcolepsy, which is a permanent disorder of wakefulness. It was rare, maybe 1 in 50,000, but it was real. But again, it occurred within weeks. The oral polio vaccine, Albert Sabin's oral polio vaccine, was a rare cause of polio, about 1 per 2.4 million doses. But again, it was because of the immune response to the vaccine and occurred within weeks. The same thing's true of myocarditis with this vaccine, or clotting associated with the J&J vaccine. That's why you have to have a 2-month follow-up after the last dose of vaccine before you submit something for licensure. But it all occurs quickly. So I don't know of any example where something pops up 5 years later or 10 years later.
All right. And then we have one last RFK quote. Let's go ahead and play that.
To replace the troubled mRNA programs, we're prioritizing the development of safer, broader vaccine strategies, like whole virus vaccines and novel platforms that don't collapse when viruses mutate.
So this whole virus vaccine, he made a big announcement about this a couple of weeks ago. He says this is the real hope for the future. This is where we should be putting our resources into. Can you just quickly tell us what is a whole virus vaccine? And is there reason to be sort of switching our bets and taking all this money out of mRNA and putting it into a whole virus?
So a whole viral vaccine is you take the virus, grow it up in cells, purify it, and then kill it with an inactivating agent, like a chemical. The first time we did that was with the rabies vaccine in the late 1800s. That's a whole killed viral vaccine. I guess the next time would have been in the 1950s with Jonas Salk's polio vaccine. Grow polio up, purify it, kill it with an inactivating agent. The hepatitis A vaccine is a whole killed viral vaccine. It's certainly not a new technology. It's been around since the late 1800s. And his notion is that would be better for this vaccine because it includes essentially all 4 viral proteins instead of just the one viral protein, the SARS-CoV-2 spike protein. Well, so that's what China did. China in 2020 introduced a whole killed viral vaccine, and it didn't work nearly as well as the mRNA vaccines. So again, he's wrong. Also, I think people should realize all viruses mutate. Every virus on the planet mutates. The only question is to what extent it mutates. So, for example, influenza mutates so much from one year to the next that natural infection one year doesn't protect against disease well the following year, so you get a yearly vaccine. Human immunodeficiency virus continues to mutate during a single infection. So it continues to mutate again and again and again. So you make an immune response initially to the first virus that you're infected with, but then it continues to mutate again and again. So that initial immune response becomes ineffective. That's why it's so hard to make a human immunodeficiency virus vaccine. Measles, like SARS-CoV-2, is a single-stranded RNA virus. So it has a very similar genome because genes are in the center of viruses, which are a blueprint for how they reproduce themselves. So measles virus continues to mutate. We've had a measles vaccine since 1963, and that virus has never mutated away from recognition by the immune response induced by vaccination. So different viruses mutate differently to a different effect. But what you can say about this virus is it's never mutated away from T-cell recognition. And although it does mutate to some extent away from antibody recognition, you still are relatively protected against severe disease. So again, I don't know what he's talking about. See, what upsets me about this is it sounds like he knows what he's talking about, right? He's using fancy scientific words like antigenic shift and mutation, but he doesn't know what he's talking about. So he's just selling you something that's not true.
Dr. Offit, thanks for spending some time with us. Appreciate it. I know our viewers and listeners do. And we'll be hopefully talking to you again in the future.
Thank you.